Okay, we're going to look at lesson 3-3 using tables and equations of lines. So we continue on with linear equations. The first one we look at is the linear equation or model that we used in a previous lesson about blood alcohol content. And as you can see, we have this equation right here. And then with that equation, this one here, we could then get the blood alcohol content level of someone after so many drinks, right? Or the time of drinks and the number of hours. So in this case, this was represented for a 150-pound man and 3 drinks. So you can see how the blood alcohol content decreases as time increases. And you can see that in this graph right here. Horizontal is the time since the first drink. And then in this case, this is for a 150-pound man who had 3 drinks. And so you can see we have this decreasing pattern here. And so in this case here, as we look at this specifically, we would be interested in knowing exactly how much does it decrease per hour. How much does it go down per hour? As you can see, I'm trying to map that out with these representation here. And what that allows us to do is then determine what's called the rate of change, how fast something is changing, right? And for a linear equation, the rate of change is constant, and so it decreases or drops by a certain amount, right? In this case, it drops by negative 0.015% or negative 0.015. And so what we're going to study here, one of the first things we talk about is what we call a slope, or the slope of a linear equation. And that slope represents a rate of change, how fast something is changing, how the values are changing. Here are some examples here. Here's a situation, $500 in 10 days. What's that rate of change if she spends at that rate, $500 in 10 days? The slope, we want to get it into a unit rate, meaning instead of 500 per 10 days, we would say $50 for 1 day. And so that's what we're looking at here, $50, and that would be what we call the slope. Some of you may have heard this, heard of this idea of rise over run in terms of when we have a graph, we can look at slope in that manner. And you can see I kind of drew that down and over, down and over. This idea of rise over run here is what we're talking about. As we're going, this line is increasing at some constant rate. And so how do we calculate that? It's the change of the output, the y value, divided by how the input or the x values are changing. So you can see this line has a slope of 2/4, 1/2, or 0.5. And so some people refer that to as rise over run. In addition, as we apply these things, we'll look at other rates of like miles per hour, how many pounds of litter per cat if we're looking at the number of cats and the pounds of litter, hours and miles, that the slope will have an important value. So keep that in mind as we're looking at and studying slope for the rest of this section.